Hi everyone, what's up? Today I want to introduce you to differential equations by separation of variables, okay? Now this is a pretty cool topic because separation of variables is a method that allows you to get into differential equations, to start solving differential equations in a very simple way, okay? You just need to know how to anti-differentiate, you just need to know how to integrate, and that's it, okay? That's how you can solve differential equations that look like this, okay? Of course, there are a lot of types of differential equations, and this is arguably the easiest type that exists. But yeah, this is it's a good place to begin. Okay, so yeah, let's do this problem. So the overall goal in a differential equation, as you know, is to find a function that satisfies this entire equation. Okay, so we need to find a function called y that, well, if we multiply the derivative of the function times x, that should be equal to 3 times the function squared, okay? That is how you can read or interpret this equation. So now let's find y. So in separation of variables, what we do is we separate all the variables that we have in the equation, and we put each one of those in one side or the other side of the equation, okay? We do that, let me show you what I mean by that before, I get ahead of myself. So how do we separate variables here? Well, remember, these are going to be differentials, okay? You shouldn't really interpret this derivative as just a single number. This is going to be a fraction that you can play with. So we're going to do the following. We're going to say that you can move dx to the other side of the equation, and you're going to get x times dy is going to be equal to 3y squared times dx, okay? This is the same differential equation, but it's just rewritten, okay? Now, if we want to separate variables, this x must go on the right-hand side of the equation, and 3y squared must go on the other side of the equation, okay? So let's see how we can do that. So you can just simply, divide both sides of the equation by x and multiply, and divide, both sides of the equation by 3y squared. So you're going to get the following. You're going to get dy divided by 3y squared is going to be equal to x, you move it to the other side, and you're going to get dx is equal to, is divided by x is equal to the left-hand side, okay? So now, this looks pretty weird, I know. This doesn't look like a derivative or like a function or anything, but this is legal in math, okay? It looks fancy, it looks funny, it looks, funny, fancy, it looks pretty weird, but that's how it goes, okay? So now, you can see that both variables, we have y on the left-hand side and x on the right-hand side. Now, we really like this form because we need to integrate to find y, okay? Remember, when you integrate, you go back, if you're integrating the nth derivative of a function, you get back to the n minus 1 derivative. This is the first derivative of y, so you have n equals 1, 1 minus 1 equals 0, so you have the 0th derivative of a function which equals the, the function itself, okay? I hope that explanation made sense. So, we want to integrate, and the only way we can do that successfully is if both variables are isolated on different sides of the equation. So now I'm going to rewrite, so I'm going to rewrite the entire thing. Now I want to integrate both sides. So I'm going to get the following. I'm going to get that I want to take the antiderivative of 1 divided by 3 times y squared dy, and on the right hand side I'm going to take the antiderivative of 1 divided by x dx, okay? This is exactly the same equation. I just simply, I separated dy and dx from the denominators, and then I'm just gonna find these derivatives, okay? These antiderivatives. So the left-hand side antiderivative is gonna give me an expression for y, okay? And this one is also gonna give me an expression for x. And then I can just, play algebra, and I'm gonna be able to find y, okay? So let's see what we can do now. We can rewrite this expression as this left-hand side antiderivative as the following. So 1 over 3 is going to be a coefficient, so you can take it outside the integral sign. So this is going to be 1 over 3 times the antiderivative of y to the minus 2 minus second power. I'm not sure how you say that in English, but yeah, anyways, this is the power that we have. So this is going to be dy, and the right-hand side of the equation, this antiderivative, it's ln of x, ln absolute value of x. We use the absolute value because 1 over x is a function that has a domain that can go to the negative numbers, okay? The domain of this function can take negative inputs, and well, just so that we can account for that, we include a absolute value in the result for this antiderivative, okay? So we know this is gonna be ln of ln of x plus c, okay? So this is what we get, and of course the c, you cannot forget the constant, that's really important. And now this derivative, this antiderivative, I'm sorry, we can compute it using the power rule, okay? So we know that we have minus 2 plus 1, that is going to be minus 1, divided by that same exponent, that is going to be minus y to the negative 1, okay? So this is going to be 1/3 times, so we had minus y to the negative 1, which is 1 over y, plus c, okay? And actually, I think I should address this, yes. You can write plus c inside the parentheses and then multiply 1/3 plus c. And well, that would, yeah, it would be okay, but usually plus c and actually this other plus c, these two constants, they're gonna, they're just gonna merge into one single constant. So usually, first of all, you don't write the constants on both sides of the equation, okay? Usually. You can do it if you feel more comfortable, but usually you shouldn't really do that because it doesn't matter what these two constants are, both of them are gonna merge into one, okay? So you just write c on one side of the equation and not on the other one, okay? And now another thing here with the parentheses and the 1/3, you can write c inside the parentheses and then multiply by 1/3. But once again, when you add this constant here, and I should write this is c1 and this is c2, when you combine c1 and c/2 divided by 3, that is going to be another constant, okay? So it's pretty much, irrelevant, or I would say it doesn't have any mathematical effect or consequence if you write c inside the parentheses or not, okay? I think that's how I should phrase that. So, just for convention, I'm not going to write it inside the parentheses. So this is going to be plus c, plus c2, and this is going to be ln, absolute value of x, plus c1, okay? So this is the expression that we now have. Now, this might seem kind of messy, but it's pretty easy. What we have to do now, we just need to solve for y, okay? So let me fix the form of this equation. So as I mentioned, these two constants, you can move c2 to the other side of the equation, and c1 minus c2, I'm going to write it here, c1 minus c2 is just going to be any constant, okay? I'm going to write, let's just say this is capital C, okay? My c's, they may not be really easy to differentiate, but this is small c and this is big C, okay? So this is going to be capital C, and we can now rewrite this equation like this. So we have minus 1/3y is going to be equal to the natural log of the absolute value of x plus positive c, okay? Positive big C, okay? So this is what we have now. Now we just simply need to solve for y. You can do the following. You can just say this is parentheses to the -1, and you're going to get that this is minus 3y is equal to 1 divided by the natural log of ln x plus c, okay, big C. And now, of course, you can just simply divide this equation by -3, and that is the result for y, okay? So we get that y is going to be, I'm going to keep this inline fraction. So this is going to be 1 divided by -3 times the natural log of absolute value of x. Now, once again, you could write minus 3c, but once again, c can be any constant. So the sign in this case, you could write minus 3c. However, if c is a negative quantity, well, you're going to get back a positive number, okay? So you shouldn't really be concerned about the negative that these 3 carries and the effect that it has on the right-hand side of the equation, because c can be any constant, okay? So really, what I should do here is just say that this is going to be plus. I should stop using c because, I don't think you can differentiate between my capital C and my small c. So let me do big C, and this is once again big C, okay? Big C's, they can be any constant, okay? That's the idea that you need to understand. So yeah, this is gonna be the derivative, the solution that we are looking for, okay? So now, differential equations are a very complex topic, and there are a lot of dimensions to this problem. There are some things that I didn't mention, and that I would say maybe are outside the scope of this video. For instance, one of them is that when you divide, remember, we began solving this differential equation with these two steps. One thing that we did was that here we divided by 3y squared and here we divided by x. Now, if you graph this function and you try to find, this is not the only solution, by the way, this is probably not the only solution to this differential equation. So one of these solutions that we left outside to this differential equation could be something that how should I put this? Could be something that mathematically we made it disappear because we divided by 3y squared equals x, okay? So yeah, I think I'm gonna make a video about that. I'm actually gonna make a video about that because that is very important. So right before this video finishes, you're gonna find another another recommended video where I talk about what happens when you divide by y or by x and how that makes a solution disappear, because you're basically, if that solution is 0, you cannot divide by 0, okay? So you're basically leaving out a solution, a zero value solution, because you divided by those quantities and then those quantities take a value of 0. Okay, this may not make sense right now, and I'm not explaining this very efficiently, but yeah, I'm gonna make a video about that, okay? So yeah, anyways, this is one of the solutions to this differential equation, and probably the one that you should care the most about. So yeah, that's been the entire video. I hope that you enjoyed it, and see you in the following one. Bye.